So our objective today is to review equivalent fractions and compare and order fractions. So let's really quickly just review equivalent fractions. You see here we have a pizza that's been cut into two pieces. The denominator of the fraction represents the number of pieces you've cut your whole into. 2 pieces, the denominator is 2. I've shaded one of those pieces, so that fraction is 1/2. We could look at the exact same pizza, but cut it into fourths. Now my denominator is going to be 4, because we have 4 pieces, and if we shade the exact same amount, we've shaded 2 of those pieces. We've got the same amount of pizza, but here we've got 1 big piece and here we've got 2 small pieces. They both equal the same amount. And we can take it one step further, same pizza, but cut it into 8 slices now. So we're dealing with eighths. Each eighth is much smaller than each half. It's going to take more of them to show the same amount. If we shade 4 eighths, we have the exact same amount as we had when we shaded 1 out of 2 pieces or 2 out of 4 pieces. So these are all equivalent fractions. Let's look at 3 different fractions that all have the same denominator. We're dealing with eighths in all 3 of these cases. That means the size of our pieces are exactly the same. In that case, where the size of the piece is the same, an eighth, all we have to do is look at the numerator, and the larger the numerator, the larger that fraction is going to be. If your slices of pizza are all the same size, if you only have 1 of them, you're not going to have as much as if you had 3 of them, and both of those are going to be smaller than if you had 7 of them. 7 eighths, another way of thinking of it, is close to a whole. If you had 8 eighths, you would actually have a whole. You've cut the pizza into 8 slices, you've eaten all 8 slices, you ate a whole pizza. So that's actually a rule in fractions. If the denominator is the same, the bigger the numerator is, the larger the fraction is. Let's look at the opposite case. Now we have our numerators are all the same, they're all 3, but our denominators are all different. The size of the piece is different. In this case, you've got a cookie that's been cut into 5 pieces, and in this case, your cookie's been cut into 10 pieces. Which of those pieces is going to be bigger? Would you rather share something between 5 people or have to share it between 10 people? This is a much smaller slice than this, half as small actually, and this is in the middle. In this case, you've cut the cookie into 8 pieces. So when the numerators are all the same, the denominator will determine which piece is larger, which fraction is larger and which is smaller. We've got 3 pieces of a larger size. We've got 3 pieces of a smaller size. So 3/5 is going to be larger than 3/8, which is going to be larger than 3/10. 3/10 is the smallest amount in this case, because although you have 3 pieces of each, you have 3 much smaller slices. If we tried to actually do that, it would look something like this. You can see a 1/10 compared to a 1/5. 3 of them. 3 of them. I know that's not perfect, but it should demonstrate pretty clearly that 3/10 is a whole lot smaller than 3/5. So the rule here is if your numerators are the same, the larger the denominator, the smaller the amount. The greater the denominator, the larger the fraction. Okay, this last case is the most difficult. We don't have any numerators or denominators that are the same. Everything is different. So how do we compare and order these? We have to really know a lot about fractions in order to do this. We have to understand what each fraction means. A half, that's one's pretty obvious. It's probably going to be right in the middle. Let's just put half in the middle. Whenever you have a fraction that's half, put that one in the middle first, and then try to place the rest of your fractions around that in a way that makes sense. What else can we tell about these fractions? Let's look at this one, 9/10. That's a pretty large amount. It only takes 10 tenths to make a whole, and we have 9 tenths. This one is really close to a whole. This is probably going to be our largest fraction, so I'm going to put it over here on this end. We've figured out that one and that one. We have 2 left. We have 3 100ths and 5 12ths. Let's look at 3 hundredths first. 100th is a very tiny amount. Imagine trying to cut a cookie up into 100 little pieces and you get 3 of them. That's a tiny amount. That tells us that 3 100ths goes down here. Definitely much smaller than a half. Wouldn't you rather have a half a cookie than 3 crumbs? So here's our last fraction, 5 12ths. How can we figure out where that goes? Does it go here or does it go here? Well, when you have a fraction that's somewhere around a half but you're not quite sure, figure out what it would take to make it a half. How many 12ths do you need to make a half? 6 12ths, right? That would be equivalent to half because 6 is half of 12. But here you only have 5 12ths. 5 12ths is just a little smaller than 6 12ths, which means it's just a little less than a half, so it goes here in our order. So when we order these fractions that have all different denominators and numerators, from smallest to largest, it goes 3 100ths, then 5 6ths, then 1/2, and then 9 tenths. So this case where all the numerators and denominators are different is by far the most difficult case that you're going to run into of ordering fractions. So these 4 fractions here are on page 129, and it's problem number 11. So right now, why don't you pause this video and see if you can do this problem on your own before I explain it, okay? Did you pause? Did you really? Okay, I trust you. So let's see if you got the same answer as I get. Our fractions are 5 9ths, 2 5ths, 1 6th, and 9 tenths. None of them are exactly a half. Do we have any that are obviously really small? This one jumps out at me. We only have 1 piece and there's 6. That's a fairly small fraction. I'm going to guess that that's going to be my smallest fraction. Do we have any that are obviously very large? Well, this one jumps out at me, 9 tenths. We're only 1 unit away from being a whole. So I'm going to put that one in my largest slot. Now I've got these 2 fractions, 5 9ths and 2 5ths. They're both fairly close to a half, but can I look at them a little closer and figure out exactly where they are? 5 9ths, is that greater than a half or less than a half? How many ninths would I need to make exactly a half? Well, half of 9 is 4.5. So this fraction is actually a little bit greater than 1/2 because I have 5 9ths, and it would only take 4.5 ninths to make a half. So this one, a little greater than a half. Let's look at 2 5ths. How many fifths do I need to make a half? I would need 2.5 fifths for this to equal a half. I only have 2 5ths, which means this fraction is just a little bit smaller than a half. 5 9ths is a little greater than a half. 2 5ths is a little smaller than a half. So now I have my answer. 2 5ths comes before 5 9ths. Okay, how did you do? Did you get the right answer? So what you should do now is go ahead and finish the rest of page 129 on your own. And as always, just do your best. If there's anything you get stuck on, just make sure you can talk to your teacher about it in the morning, and we'll go over these problems in class tomorrow. Okay, have fun.